Hello everyone, welcome. In this video we will learn how to use NNToolbox, which is a Matlab app. We can use this app to design and train neural networks without writing a single line of code. So let's get straight to it. So let's start by looking at the dataset. Here we have the dataset. You can continue the tutorial using any dataset you like. In this dataset we can see in each column we have 10 input variables and one single output. And there are two types of output, 50 and 10. So how this works is when I've put down the summation of each column here. So this is the summation of each column. So you can see when the summation of each column is higher, around 60 to 60 plus, our output is 50. And when the summation is lower, around 20 to 30, the output is 10. So this is the differentiative factor in the dataset, which our network should be able to catch. And here we can see in the graph, so when the summation is higher, around 60 to 70, our network should be able to predict output, a higher output, which is 50. And when the summation is lower, around 20 to 30, our network should be able to predict a lower output, which is 10. So let's get to Matlab. So in Matlab, we're going to open two variables. Let's name one input and call other target. So in input, we're going to paste the input data, and in target, we're going to paste the output data. So we have our two variables ready. So what you want to do, you always want to put your inputs in a column. NNToolbox will read each column as input. So we have 10 input and 1 output, and total 12 datas in our dataset. So now let's open NNToolbox. Just type NNTool in command window, hit enter. We have our NNToolbox. First we have to import these datas into our NNToolbox. Click import. We can import from Matlab workspace and also from our computers directly. So here we can see all the variables that are currently in our workspace. We have two, input and target. Select input and import as input data. Select target and import as target data. So we have imported our datas. Now we have to define our network. Click new. So first you can put in any name you want. In network type, we are sticking with feed forward back propagation. Input data, input, target data, target. Selecting our variables. Training function, let's put, there are a lot of functions. We're gonna put train GDX. Here we have adaptive learning rate in train GDX. Performance function is basically our error function, MSC, mean squared error. Okay, two number of layers, that's gonna be okay. In layer 1, let's put 5 neurons. You can put any neuron you want, any number of neurons. It's basically trial and error. And transfer function should be logarithmic function, logarithmic sigmoid function. We can see our network, click view, and this is what our network structure looks like. We have 10 inputs, 1 hidden layer, 1 output, and in the hidden layer we have 5 neurons. Okay, let's create the network. Okay, now we are going to train our network. Double click on network 1 and we'll have this window. Here we can see our network structure again. Go to training tab. We have to select the training data. Here we can change our training parameters. Let's stick with the defaults and see what we have. Okay, we have only 8 iterations, which is very low. So in the performance plot, we can see the error is minimizing. So the curve is going down, which means it's minimizing. And let's see our regression. And the regression is bad. An ideal regression line should look like this dotted line here. So we have to train more. Okay, so let's change our training parameters and let's see. So validation fails, maximum validation fails, let's put 1000, and minimum gradient, let's put 10 to the power minus 6. Okay, now let's train our network. So here you can see you have trained for 312 iterations. So why the network stopped training is because we have reached our minimum gradient, which we have selected in our parameters. So what it means is we can see here that we cannot see the blue line, which is our training data. So what happened is we were minimizing the error, and now we have a straight line. That means the error is not minimizing at a good rate, and which is our gradient. So a lower gradient means you are not minimizing your error. Okay, let's look at the regression line. So we have a better regression line than the previous one. It's not the perfect one because our network is not predicting the proper outputs. So what it means is in the x-axis we have our target data, so what our network should predict, and in the y-axis we have our output data, what our network is predicting. So it should predict 10 and 50, we already know that, but it's predicting 30 and 50 for some reason. Well, let's see our outputs. We can check our outputs here. So whenever you train a network, outputs should be always exported to this tab. So let's compare to our outputs. So we can see we have 50, but our networks cannot predict 10. It's predicting 30. So I think what is happening actually, the error minimizing function is stuck at some kind of local minimum. What we want to do is find the global minimum. If we find the global minimum, our network will predict 50 and 10, but it's stuck at local minimum. So with this type of network structure, I don't think we can ever get to a global minimum, because this is a very basic neural network. But the important thing is our network can differentiate between the two datas. That will be it for this video. If you enjoyed this video, don't forget to like the video, subscribe to the channel, and also hit the bell icon, because in the next video we will be working with MNIST dataset. We will design a more complex neural network to classify the MNIST data, hopefully. So see you guys on the next one.